Okay, so let's go ahead and take a look at this problem set. So we're going to deal with some absolute value. When you solve absolute value equations, the first thing you need to do is isolate the absolute value. So I'm going to do that here. I'm moving the 4 to the other side. So then I can divide both sides by 3. So I'm getting the absolute value by itself. Now, once I get the absolute value by myself, then I have an x plus 1 is equal to 3, and then an x plus 1 is equal to negative 3. So I get x is equal to 2, and x is equal to negative 4. So in interval notation, negative 4, comma 2. Okay? And then, again, same idea, isolate the absolute value. So I get negative 2 is equal to negative x minus 3. So then 2 is equal to x minus 3. So then x minus 3 is equal to 2, or x minus 3 is equal to negative 2. So then x is equal to 5, or x is equal to 1. So 1 or 5 in set notation. And so that curly bracket just means that x is equal to that. So it is like what's called set notation. Okay, so now we're going to write things in interval notation. So going to number 5, when it's greater than, we split it into 2. So 3x minus 5 is bigger than or equal to 13. So all we do is, for the first one, we just drop the absolute value. Then we do the same thing, but we make the absolute value equal to negative 1. And then we solve. So I add 5 to both sides, so 3x is bigger than or equal to 18. So x is bigger than or equal to 6. And then 3x minus 5 is less than or equal to negative 13. So remember, when you divide by a positive or by a negative number, that you have to switch to the direction of the inequality sign. So anytime you multiply or divide by a negative 1, you have to switch the inequality symbol. Okay, so then you get 3x is less than or equal to, we're going to add 5 to both sides, so I get negative 8. Divide both sides by 3, so x is less than or equal to negative 8/3. So then you want in between. So I want all the solutions. So that means I'm less than 8/3 and bigger than 6. So that would be negative infinity to negative 8/3, closed bracket, because it can be equal to, union 6 to positive infinity. Okay. Now, I did one with greater than, so that also means I have to do one with less than. So we'll do this one here. And when you do less than, what you do is you drop the absolute value. You have your 3x minus 4. And then you sandwich it between a positive 8 and a negative 8. And then what you do to the middle, you do to both sides also. So I'm going to add 4 to everybody. So I get negative 4 less than or equal to 3x less than or equal to 12. And then what you're going to do is you're going to divide everybody by 3. Oops, not negative 3. So then you get negative 4/3 is less than or equal to x, which is less than or equal to 4. And so your interval notation is closed bracket at negative 4/3, union, sorry, not union, and then closed bracket at 4. You only need the union symbol in something where, like number 5, where we had 2 intervals that are separated. You do need to make sure they use the U for union. I will not accept and. I won't also accept commas either. So sometimes you guys put commas, and that's not the case either. Okay, let's take a look at number 9. When I look at number 9, I'm looking at describing all the numbers that are a distance 4 away from the number 8. So when I do this, I have 8 in the middle, 4 in one direction is 12, 4 in the other direction is 4. So absolute value is the distance away from the 0 point, and so that is at 4. Because I'm going both directions, and so I'm getting this closed interval that's here. What I'm looking at is a less than or equal to symbol. And what you do is you put the middle point, so the midpoint of the interval in the absolute value, and then you put the distance away from that middle point to each end point as what is equal to or not equal to in your inequality. So it's either, like if it's an equality, obviously it's just equals, but your distance away, this 4 represents the distance away from the middle point in the interval. Okay. All right. And that is it for this lesson.